ही आहेत लॉंग आन्सर क्वेश्चनचे आन्सर्स. फर्स्ट क्वेश्चन्स एक्सप्लेन. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने जी 2023मध्ये क्वेश्चन बँक पाठवली होती फिजिक्सची, आणि त्याचे आज आपण आन्सर की बघणार आहोत. आपला कायनेटिक थिअरी ऑफ गॅसेस अँड रेडिएशन चॅप्टर चालू आहे. आज आपण लॉंग आन्सर बघणार आहोत. चला तर मग लॉंग आन्सरकडे जाऊया. ही आहेत लॉंग आन्सर 4 मार्किचला. ह्याची आन्सर आपण पुढील प्रमाणे PDF स्वरूपात बघूया. ही आहेत लॉंग आन्सर क्वेश्चनचे आन्सर्स. फर्स्ट क्वेश्चन्स एक्सप्लेन द स्पेक्ट्रल डिस्ट्रीब्युशन्स ऑफ ब्लॅक बॉडी रेडिएशन. First, the rate of emission per unit area or power per unit area of a surface is defined as a function of the wavelength lambda of the emitted radiation. Second, scientists studied the energy distributions of black body radiation as a function of wavelength, radiated power and wavelength. Third point, by a keeping of the source of radiation, means such as a cavity radiator, at a different temperature they measure the radiate power corresponding to the different wavelength. The measurement were represent the graphically in the form of curves show the variations of the radiant power per unit area as a function of wavelength lambda at a different constant temperature as shown in figure. Question number second, derive expression for average pressure of an ideal gas. First point, let there be an mole of ideal gas enclosed in cubical box of volume V is equal to L cube with sides of the box parallel to the coordinate axis as shown in figure. The wall of the box are kept at a constant temperature. Second, the gas molecules are in a continuous random motion, colliding with each other and hitting the wall of the box and bouncing back. Third, as per one as the assumptions, we neglected intermolecular collision and consider only elastic collision with the walls. He diagram आहे. Fourth point, a typically molecule moving with the velocity v bar about the collide elastically with the shaded wall of the cube parallel to YZ plane. Fifth, during the elastic collision, the component Vx of the velocity will get reversed, keeping Vy and Vz component unaltered. So, 6. Hence, the change in the moment of the particle is only in the x component of the momentum. Delta px is given by delta px is equal to final momentum minus initial momentum is equal to minus mvx is equal to minus 2 mvx. Seventh, thus the moment of the transferred to the wall during the collision is 2 plus mvx. The rebounced molecule then goes to the opposite wall and collides with it. 8. After the colliding with the shaded wall of the molecule, travel to the opposite wall and travel back toward the shaded wall again. 9. This means that is the molecule travel a distance of 12 is in between two collision. 10th, as L is the length of the cubic box, the time for the molecule to travel the back and forth of the shaded wall is delta T is equal to 2L divided by Vx. 11th, average force exerted on the shaded wall by molecule 1 is given as the average force is equal to average rate change of momentum. First equation आहे इथे the average pressure P is equal to average force divided by average of shaded wall. ते फॉर्म्युला आहे एम इज इक्वल टू Vx1 स्क्वेअर प्लस Vx2 स्क्वेअर प्लस डॉट 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 डिवाइड L1 into L2 square. 13 the average square of the component of the velocities is given by the formula दिलेला आहे खाली therefore p is equal to mn vx square bar divided by v and where vx bar is square bar is the average over all possible value of vx. Therefore, average pressure P is equal to 1 by 3 n by V mv bar square. Derive question number 3. Derive Myers relations. Consider one molecule of an ideal gas that is enclosed in the cylinder by light frictionless airtight pistons. Second, let P and V and T is the pressure, volume and temperature respectively of the gas. Third, if the gas is heated so that the temperature rises by dT but the volume remains constant, then the amount of heat supplied to a gas dq1 is used to increase the internal energy of the gas. D. Since volume of the gas is constant, no work is done in moving the piston. Equation first I on other hand, if the gas heated to the same temperature at constant pressure, volume of the gas increased by an amount say dV, the moment of heat supplied to the gas is used to increase the internal energy of the gas as well as to move the piston backward to allow the expansion of the gas. The work done of the move the piston dW is equal to pdV. Option second equation. A third equation Cp minus Cv is equal to dt dV is equal to pdV. For 1 mole of the gas, Pv is equal to RT. Seventh, also Cp is equal to m0 Sp and Cv is equal to m0 Sv, where m0 is the molar mass of the gas and Sp and Sv are the respective principal specific heat. Thus, m0 Sp minus m0 Sv is equal to R by J, where J is the mechanical equivalent of the heat. Sp is minus Sv is equal to R by m0 into J. इथे आपले लॉंग आन्सर क्वेश्चन संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.